Hi friends, welcome to the class of Formal Language and Automata Theory. In the previous lecture we have seen the minimization of DFA by using equivalence method. Now we will go for table filling method. So how to solve by using table filling method? Anyway, the step 1 is you need to first find non-reachable states and you need to remove non-reachable states. So what are non-reachable states here? Only Q5. I have to remove Q5 here. Now second step, again consider, first go for transition table for the respective transition diagram. I have taken this is a transition table. Now in table filling method, first you take a table. How many states are there? 1 2 3 4 5. You take 5 by 5 table, 5 by 5 table, and try to write like this, starting from here: Q0, Q1, Q2, Q3, Q4. Here also Q0, Q1, Q2, Q3, Q4. Now no need to take all the cells. Here the logic is, first you take diagonal. So this is the diagonal. What is the cell name? Q0, Q1, Q0. So Q0 to Q0 no need to find. So you cross it. Q1 to Q1, Q2 to Q2, Q3 to Q3, Q4 to Q4. And not only that, what is this cell represents? That means each cell you represent it as a pair of states. Now you see this one, what is this cell? Q1, and for this Q0. This cell represent Q0, Q1. What about this cell? This is also Q0, Q1. So both cells represent the same. So why should we need to take both? We need to consider any one. So that's why. And also you can observe Q2, Q3. This is the cell name is Q2, Q3. And you can see this one, this is also Q2, Q3. That's why whatever are there in the right side of this diagonal, all are coming twice. So that's why instead of taking both sides, I have to take any one side. That's why I'll make all these are not required. So if you take like this, so that only these cells which are required for us. Okay, remember like this. And now you need to fill this. How to fill, I'll explain here. You can see one by one. Yeah, first this cell. What is this cell? You see, what is this cell? Q0, Q1 pair. So I'm writing here the pair Q0, Q1. Now what you need to do is check out these two states. Whether both are non-final, not a problem. But whether both are final, not a problem. But if one is final, one is non-final, then mark that cell. So you can see here the first one Q0, Q1, Q0, Q1, both are non-final. No need to mark now. Now coming to here, Q2, Q0, Q0, Q2, both are non-final. Q2, Q1, both are non-final. Q3, Q0, both are non-final. Q3, Q1, both are non-final. Q3, Q2, both are non-final. Now coming to this one, Q4, Q0, you can see Q0 is a non-final, Q4 is a final. So if I take Q0, Q4 pair, one is non-final, one is final. So that's why that cell I have to mark. Now what about Q4, Q1? Q4 non-final, Q4 final. So mark. And remember, if both are final, no need to mark. Anyway, you have only one final state now. That instant you can't find here. So Q4, Q2. Again mark. Why? Because Q2 non-final, Q4 final. What about Q3, Q4 cell? So one is Q3 is non-final, Q4 is final. Mark it. Now in the second iteration, next again go to this one, Q1, Q0. The cell is Q0, Q1. Check out what is Q0 to A and what is Q1 to A. Why? Because we are taking this pair now. That's why Q0 to A, Q1 to A. Both are same, then ignore. That is Q0 to A, Q1 to A, both are same. I am ignoring. And Q0 to B, Q1 to B, I need to check. Q0 to B, Q2, Q1 to B, Q3. Now what is the resultant pair you are getting? What is it? Q2, Q3. So the pair is Q2, Q3. Check out in these cells. Where is Q2, Q3? Here only you need to check out. You forget about this one. So I'll put like this to avoid confusion. Now where is Q2 Q3 cell? You can see here, yeah, here is Q2 Q3 cell. So is it marked? No. That's why no need to mark Q0 Q1, this cell Q0 Q1 Q0. Now the second one, now I'm going to see, you can see, observe, I'm coming from here, then here, then here, like this, whichever are not marked. So coming to here, this is Q0 Q2 cell, Q0 Q2, you can see Q0 to A Q1, Q2 to A Q1, both are equal, ignore. Q0 to B Q2, Q2 to B Q2, both are equal, then also ignore. So no need to mark for Q0 Q2. Now coming to this one, Q1 Q2, Q1 Q2. So I'm writing here Q1 Q2. So Q1 to A Q1, Q2 to A Q1, both are equal, ignore. Q1 to B Q3, Q2 to B Q2. So I'm getting the pair that is Q2 Q3. Q2 Q3, is it marked? No. So no need to mark here also. Now coming to the next one, this is Q0 Q3. You can see Q0 Q3 pair. I'm writing here Q0 Q3 pair. So Q0 to A Q1, Q3 to A Q1, both are equal, ignore. Q0 to B Q2, Q3 to B Q4. So you can see what is the pair you are getting? Q2 Q4. No. Now check out where is Q2 Q4. Here. Is it marked? Yes, marked. That's why whatever we are finding now, Q0 Q3, no, so that is also should be marked. So like this you need to get when to mark and when not to mark. Now coming to Q3 Q1, Q1 to A, Q3 to A, same, ignore. Q1 to B, that is Q3, Q2 to, that is Q3 to B Q4. You are getting Q3 Q4. Where is Q3 Q4? Yeah, here is Q3 Q4. So it is marked, that's why this also to be marked. Now coming to Q2 Q3. So Q2 to A Q1, Q2 Q3 to A Q1, that is ignore. Q2 to B, Q3 to B, Q2 Q4. Where is Q2 Q4? You can see here. Is it marked? Yes. So that's why this also to be marked. So source pair whatever you are taking, for that whether to mark or not, that we are checking. Now this is second iteration over. Now third iteration. Again coming to this, what is this? Q0 Q1. So Q0 Q1, what is Q0 to A Q1, Q1 to A Q1, both are equal, ignore. Q0 to B Q1 to B, Q2 Q3. Check out where is Q2 Q3 here in this. And one more thing I am saying, don't go this side, this is all ignored. So Q2 Q3, where is Q2 Q3? Yes, here. Is it marked? Yes. So mark it. Now coming to Q2 Q0, Q0 A Q1, Q2 to A Q1, ignore. Q0 to B, Q2 to B, both are Q2, ignore. This part is ignored. Next, Q1 Q2, Q1 to A Q1, Q2 to A Q1, ignore. Q1 to B, that is Q3, Q2 to B Q2. So Q3 Q2 you are getting. Where is Q2 Q3? Yes, here. Is it marked? Yes. So here also to be marked. So over. Now fourth iteration, even if you go again checking for Q0 Q2, both are same, ignore. That's why until you will get no changes, you need to proceed like this. Now check out which cell is unmarked. So only this cell is unmarked, you just put it as equals to and tell me what is that cell, that's a pair, Q to Q0. Now I can say that whatever the resultant I am getting, those two states are equivalent. So that's why I can make these two are as a one state. Now I can get the resultant finite automata here, Q0 Q2 as a one group, here Q1, and here Q2, anyway it is combined, Q3, this is Q4. Anyway Q5 is non-reachable, that's why we are not taking. Q4 is the final state. And Q0 to A, what is Q0 to A? Q1, Q0 to B, Q2, of course in this only, that's why self loop. Q1 to A, self loop. Q1 to B, Q3, Q2 anyway no need to take because it is combined. Q3 to A, Q1, Q3 to B, Q4, Q4 to A, Q1, Q4 to be Q2. So like this you need to consider. Anyway, Q4 is the final state. So now you can see the resultant deterministic finite automata, where you find only 4 states, and in the source you have 6 states. We have reduced the states and the transitions also. So this is a method, we call it as table filling method. And one more thing you can remember, sometimes you may get some sort of the states, like I'll give that program also, like somewhere you will find Q0, Q2, Q1, Q2 and Q0, Q1. All these are, you will find here equal. That means what? Q0, Q2 equal, Q1, Q2 equal means you can say that Q0, Q1 are also equal. Like this, if you find, you can say that Q0, Q1, Q2, all these 3 states are equal. That means these 3 should be combined. Like this, we have some other examples. So we'll see some more concepts in the next video lecture. Thank you.